In this problem, we want to evaluate the volume of a shape obtained by rotating this region about the y-axis. So let's just have a quick sketch, a small sketch here. So the graph of y equal to square root of x is something like that. If you don't sketch it properly, accurately, it really does not matter. Just have a quick idea of what shape we are referring to. So when this shape, and they said from 0 to 4, so for example, this is 0 and this is 4. So basically, if we are rotating this part around the y-axis, what we get is some sort of a conical shape like this. It is kind of made of circles. Not easy to sketch, but something like this would be created. It's a three-dimensional shape, and what we want to evaluate is the volume of this conical shape. So to do that, what we want to do is, which is one of the easiest methods, is the disk method. So we can imagine that this volume is made of lots of tiny disks. So let me just take out this disk out here. What I would see, that would be a very thin disk there, very thin cylinder. And if I pick another layer on top, it would be another cylinder which is bigger. So, but what is the, and what we want to do is we want to stack all of these cylinders on top of each other to create this final shape. So let's see what is the volume of one of these disks. Volume of this disk is the height of that multiplied by the area of the base of that. The base of the circle, the base of the cross section of that cylinder is a circle. So the area of this would be area of a circle, which is pi r squared. And the thickness of that, because it's a very, very thin layer along the y-axis, we would refer to that as dy. If it was along x-axis, it would be called dx. So basically, the volume of this tiny thin cylinder is pi r squared dy. And we have infinite number of these disks stacked on top of each other to create that volume. So to get the overall volume, we need to add up all of these tiny volumes, which we basically sum them up or we integrate these. So we want to integrate that, but the problem here is we have r here and we are taking the integral with respect to y. So we need to write r in terms of y. Let's see what is r. R of this disk here is basically distance of this function from the y-axis. But at any y value, we have different radius. So, and what is the radius? The radius basically is the x coordinate of that point. So from this function, which is kind of controlling and dictating the radius, we need to know what is the x coordinate, which is basically representing the radius of that layer. So y is equal to square root of x, and we know that x is equal to the radius. So let's solve for x. Let's square both sides. So we get y squared is equal to x. So now we can say, okay, y squared is basically the radius. Now we can take that integral easily. We have the integral of pi r squared, which is the radius, which is y squared, and dy. But this should be a bounded integral. It's a definite integral. It has a lower bound and the upper bound, and both of them make sure that these are not 0 and 4. These are supposed to be the y values, because you are taking the integral with respect to y. So the lower bound would be this point, which is y0, and the upper bound would be this y. But what is that y? We get the y from the function. So we plug in the 0 here, we get the y equal to 0 as a lower bound. And if I plug in the upper bound 4 into this function, I get the upper bound, which is 2. The square root of 4 is 2. So we have this integral. Now it gives us the volume of this shape. So let's evaluate that. So instead of y squared, we simply can write that as pi y to the power of 4 dy. And pi is a constant, it stays there. And we simply take the integral of y to the power of 4, which is a simple power rule. So it would be y to the power of 5 over 5. This is a definite integral, so we don't need to add the plus c, and we just put the upper bound and the lower bound 0 to 2. So we first plug in the upper bound, so we get pi 2 to the power of 5 over 5, minus when we plug in the lower bound, which is pi 0 to the power of 5 over 5, which makes the second part entirely 0. So overall, the volume would be just this part, which is pi times 2 to the power of 5, which is 32 over 5. This would be the volume of shape, which is made by rotating this region about the y-axis.